Hello everyone. Today I will be talking about data structures and algorithms. So this is the first video of DSA series. So let us understand why we need to learn data structures. Data structure is a way of collecting and organizing data in such a way that we can perform operations on these data in an effective way. There's a difference between class and data structure. Class also does the same thing. It collects different types of data under one single entity. The only difference being data structure provides techniques to access and manipulate data efficiently. Data structures are a means to store the data orderly so that various operations can be performed on it efficiently. Data structures should be designed and implemented in such a way that it reduces the complexity and increases the efficiency. So the basic data structures are int, float, char, etc. And the abstract data types are linked list, tree, graph, stack, queue, etc. So we select the data structures based on the type of operation we require. So let us understand the classification of data structures. First one is linear and non-linear. Data types that are arranged in linear sequence. For example, arrays, linked list. It's because it's like 0, 1, 2, 3. But there are non-linear data structures which are not in sequence. For example, tree, graph. Then we have homogeneous, or that is all the elements are of same type. For example, arrays. If it is an integer array, then every element in that will be an integer. Non-homogeneous data elements may not be of the same type. Example, structures. Then we have static, whose size and associated memory locations are fixed at a compile time. Example, array. Then we have dynamic, those structures which expand or shrink depending upon the program needs. Their associated memory locations may also change. For example, linked list. You know that in coming videos we'll be learning about linked list. In linked list, the we have nodes, and it depends upon the data, and according to that it expands and shrinks. Now let us learn the role algorithms. Now the role of algorithms. What is algorithm? Algorithm is a finite set of instructions or logic written in order to accomplish a certain predefined task. The logic of a program is expressed informally in some pseudocode, not based on any programming language. Every algorithm must satisfy the following properties. Input: there should be zero or more inputs supplied externally to the algorithm. The output: there should be at least one output obtained. Definiteness: every step of the algorithm should be clear and well defined. Finiteness: the algorithm should have finite number of steps. Correctness: every step of the algorithm must generate a correct output. So these are the five properties which an algorithm must satisfy. Performance of the algorithm. An algorithm is said to be efficient and fast if it takes less time to execute and consumes less memory space. The performance of an algorithm is measured on the basis of the following properties: time complexity and space complexity. Time complexity is a way to represent the amount of time required by the program to run till its completion. It's generally a good practice to keep the time required to a minimum. Space complexity: it is the amount of memory space required by the algorithm during the course of its execution. It is the amount of memory space required by the algorithm during the course of its execution. So these are the two metrics which decide the performance of the algorithm. Relationship between organization of the data and efficiency of the algorithm. For example, telephone directory of people contains name, telephone number, etc. in a large city is to be maintained. Suppose the entries are unsorted, then how will we search for an entry? If the entries are in sorted order of names, then searching for an entry. So these are two cases. I can understand if the entries are unsorted, it will be harder, and if it is sorted, it will be easier. So, in summary, a data structure is a specialized format for organizing, processing, retrieving, and storing data. Each data structure contains information about the data values, relationships between the data, and functions that can be applied to the data. In computer programming, a data structure may be selected or designed to store data for the purpose of working on it with various algorithms. The main operations we have to study about the data structure is how to search, sort, insert, delete elements in various structure. So these are the things which we need to learn. In the next video, we'll be talking about arrays. Thank you for watching.